Hello, so now today we will be solving the 2-sum problem. So let's see the problem first. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. So we are given an array of numbers and one integer, which is our target, and we are expected to return the indices of two numbers such that these two numbers add up to our target. And they have also given us that you may assume that each input would have exactly one solution and you may not use the same element twice. That's good. And okay, so they have given us you can return the answer in any order as well. So yeah, so what is our inputs? We can see that our input is one array and a integer target, and our output is going to be array with the two indices. Okay, so let's see the constraints and think about any edge cases which we are able to come up. First thing is, what if the array is empty? Okay, what to return in that case? But as we can see here, the constraints they have given us that the array length is going to be minimum 2. So we don't have to worry about 0 and 1 length inputs here. And as we can see, the target is well within the range of inputs. So it is not going to exceed that. And we are also given that only one valid answer exists. So there are not going to be any conflicting answers. There's only one valid solution in the whole array itself. Okay, so let's continue. Okay, so this is one of the examples where they have given 2, 7, 11, 15 and 9 is our target. And as we can see, 2 and 7 add up to 9. So that's our answer. Similarly, we have 3, 2, 4. 2 and 4 adds to 6. So your answer is 1, 2. Again, 3 and 3 is given and target is 6. So they have mentioned here that the same element cannot be repeated twice. But here, as you can see, it is two different elements. Even though the numbers are same, they are two different elements. So we return 0 and 1 as an answer. So let's first start with a brute force approach. So what we can do is, for each element in our array, let's iterate and check with each other elements in the array. For example, in this array we have 3, 2, 4. Now let's add 3 with 2. It is 5. It's not equal to 6. 3 with 4. It is 7. It is not equal to 6. Again, then we come here, 2 with 4. It is 6. So that is our answer. Okay, so that solution, I've given that solution here. So for I in range, length of nums. For j in range, length of nums. Here what we can do is, we can either probably, okay, I've published this. Yeah, we can even just iterate j from I plus 1. Okay, so if that's the case, you can ignore this part. Okay, and if nums of I plus nums of j equal to target, then you just return I and j. So this is our brute force approach. So what is the time complexity of this approach? As you can see, we are iterating it. You have nested for loops here, 2 for loops, so it is O of n square. So if there are 10 elements in your array, so you would iterate it 100 times. And what is the space complexity? Here we are not storing anything anywhere, so our space complexity is O of 1. Now let's think about a better approach. So here, assume that you sort this list, okay, and we can use a 2-pointer approach. Okay, so let me probably just show you with an example here. Okay, let's just take one examples from here itself and add a few more. So what I am doing is, I'm taking this example first. Yeah, so we have, the array has 3, 2 and 4. Okay, now how will we sort this? So we can just sort it to 2, 3, 4 but we will lose the information about the indices here. So in order to preserve the indices, what we can do is we can first store the indices of each number in a tuple. How will we do that? So we will have as 3, 0, 2, 1, 4, 2, and then sort it based on the 0 index. So what we will get is 2, 1, 3, 0, 4, 2. So this will be our sorted array. Now what we will do is we will have our first pointer here, the second pointer here. So 2 plus 4 equals to your target. The target they have given us 6. So 2 plus 4 equal to 6. So we return 1 and 2. So you return 1, 2. That will be your answer. Okay, the same thing I've added it here as well with a few more numbers, so that like what we have to do if they do not sum up to the target. Here luckily we were able to get to target instantly with the first iteration itself. Okay, so I've just added 1 and 6 in this. So initially our left pointer is at the first position and our right pointer is at the last position. So here 1 plus 6 is equals to 7. 7 is greater than our target 6. So we move the right pointer here. Okay, so we decrease the right pointer by 1. Okay, now 1 plus 4 is 5. 5 is less than 6. So we need to increase our left pointer here. And then we again come back to 2 and 4, which is equal to 6, and return 1, 2. So the code for this is here. So initially what I'm doing is I'm creating a tuple by iterating all the numbers and then sorting those numbers based on x of 1. So here I did it using x of 0, instead x of 1. So here instead of saying it as 3, 0, it will be 0, 3, 1, 2, and 2, 4. Okay. And then we have left and right pointers, which are 0 and the last element. While left is less than right, current sum is equals to, you just add those two numbers. And if it is less than target, you increase your left pointer. If it is greater than target, you decrease your right pointer, else you return whatever is there. So now what is the time complexity for this case? The time complexity here, as you can see, is O of n for creating a new tuple. Then O of n log n for the sorting. And then O of n by 2 for the 2-pointer approach. So it is O of n log n. Now coming to space complexity, we are storing it in a new array by using a tuple. Assume if it is a given, the given array itself is sorted. If that's the case, then this would be the optimal approach. Okay, so here space complexity is O of n, as we are creating a new array by storing the tuple values. So it is O of n log n, O of n. So now let's try to decrease our time complexity a little more. Okay, anyway we are using O of n space complexity. Then why to waste time by sorting it? Okay, so let's use a hash map. Why do we use a hash map? Because we just do not want the numbers. Okay, if the problem statement was return the numbers itself. So instead of returning it as 1, 2 here, you have to return 2, 4. The numbers that returns the target. If that's the case, then we can use a set. But as we need to store the indices, so we'll go for hash map. Okay, and if the target minus nums of I is already present in the hash map, then that means that we have already seen the pair for this number that gives you target. So you return those two indices. Else you add nums of I to the hash map. Okay, so now let's see with the example. Okay, I'll take the same 3, 2, 4, and we have target is equals to 6. Okay, and this is my hash map. I'll just put it like this. So first what we see is we see 3. Okay, we then look in the hash map whether we have 6 minus 3, which is equals to 3 in the hash map. We don't have that. So what we do is we put 3 is the 0 is at the 0th index. Okay, then we now go to the next element, so which is 2. So now 6 minus 2 equal to 4. We check whether 4 is there in the hash map. It is not there. So what we do, we add 2. We add 2 to the hash map. Again, next we go to the next element, which is 4. 6 minus 4 equal to 2. We have 2 in our hash map. So what we do is we return 1, 2. So 1 is from this one, 2 is this index. 0, 1, 2, right? 2 is the index, so we return that. So this is the optimal approach. Okay, the code for it is, it's very simple. You have a dictionary, okay, which is your hash map. Then for I comma num in nums, so we iterate the numbers. If okay, what I'm enumerating because I need the indices as well. If target minus num in numdict, return this the value of the target minus num. So which is what we did 2, right? Comma the current one. If not, you add this number to the hash map. So the time complexity for this is O of n, because the amortized time complexity of hash map lookup in hash map is O of 1. So the O of n is only for the iteration. The time complexity is O of n, and the space complexity is also O of n, as we are storing all the n numbers. So that's it. I hope you understood this problem. Thank you so much.